So, hello everyone, I hope you can hear me. Welcome to this webinar here at Etteplan. This is the first webinar in a series of several that will come during the coming year within the medtech area. My name is Morten Jansson. I'm working as a regional responsible for engineering solutions in the south of Sweden. I will today act as moderator, and I will soon let the word over to our speaker for today, Peter Dahlberg. But first of all, I would like to say a few words regarding Etteplan services within the medtech area. We have been working with the medtech area for almost 30 years. We have a quality management system that is certified to ISO 13485, and this means that we could be a partner for both big and small companies, and we can take responsibility from ID to production start. This also, of course, means that we can work in the customer's quality management system, or we can do the development in our quality management system. We have all the different competences, technical competences needed to do this at Etteplan. We also have regulatory competences and so on. But important when developing those type of projects is also that you have workshops, the facilities around that. For example, we have EMC labs that is certified. So that's a thing to keep in mind when we work regarding this. During this webinar, you have the possibility to make questions or write questions. You can do that in the question field or in the chat field, and afterwards we will try to answer some of the questions. And those questions that we don't have the possibility to answer here today, we will get back to you with answers or a discussion regarding those. But now I'll let the word over to you, Peter.
Yes, hello. And once again, welcome to this webinar. I hope you can hear me. I am Peter Dahlberg, and I've been working within product development for about 10 years. And after that, I took over as manager for the Etteplan office here in Uppsala 2 years ago. And I'm now managing a team of about 20 engineers here, and we have a broad in-house experience from different project deliveries. And on as a person, I really like to being outdoors, as you can see on these images, just to give you a little bit hint about myself here. So today's scope, I would like to introduce how we approach an innovation or a development project in the early phases of this. And I would say that this is more of a mindset than a process. So hopefully you can take parts of this and maybe apply to your own reality in your own companies. And I will try to cover some things here, as you can see, trends in product development that we can see. I also would like to explain why we have this mindset. Talk something about requirements versus hypothesis, and also different ways of verifying our hypothesis. Some words about minimum viable products and what we put into that word or words, and also what kind of benefits we can see with this approach, and the critical factors for success. And in the end, I will show you also a little case to show you how it could look in reality. So first of all, I would like to show you a high-level picture of our development process within Etteplan. This is a very high level, and well, the 4 main phases that we go through in a project. Usually we start off with a pre-study, and then we have an iterative definition phase, as we call it, and then productization, and finally you enter production. And this webinar will mainly cover the iterative phase here. That's quite early in the project and a way of defining your requirements. So, what trends are we seeing in product development out on the market? Well, we can see that more and more companies are going towards an agile approach. This is not something completely new. It's been present quite many years, and primarily within software development, I would say. But nowadays, you tend to move over to this agile approach only within other fields of product development. And instead of then in a traditional model where you try to fix your requirements as early as possible, and then time and budget sort of had to adapt to that, and sometimes projects became very long and expensive. Instead, today you usually have a fixed amount of time and a fixed budget for a project, and then you need to adapt your specifications to that, and you need to work in a structured manner to achieve a success in your project. And I can add that to this picture, that what made this possible are those new tools within 3D printing and standard electronic components that is available today, and they weren't 10 years ago. So now it's possible to do it in those other fields. So I will try to show you a project journey to explain a bit further what we're trying to achieve here. And if you start on the left-hand side, you start up your project, and we believe that this first orange phase, there you should handle most of your requirements as assumptions instead. And that's the agile approach. And at a certain time, when you've done experiments, you've tried to verify that your assumptions are correct, then you turn into a more traditional way of working. And you have a well-defined requirement specification. Hopefully there are relevant and realistic requirements there. And you handle those requirements more traditionally, and you try to verify and validate them towards the requirement specification. Another picture trying to visualize and explain why we're doing this. On the left-hand side, you can see a project journey that we would like to try to avoid. You discover a problem late in the project, and it has critical impact, and you have to start more or less all over again until you can finalize your project. On the other hand, on the right-hand side, you can see this, what we want to try to achieve. Of course, you have setbacks, but you have an iterative approach, and you take small steps forward all the time and no surprises in the end. So that's a much better sort of journey than the one on the left. And how can we achieve this then? This is a visualization of our iterative cycle during this phase in the project, to give you an overview of the activities that we do. And first of all, number one in the top middle, we try to identify the most critical assumptions that we've done in our product concept. And you probably have a vision of what you want to create, and you have a concept, maybe also technical solutions that you believe will work. But in this stage, you should try to identify what assumptions did I do in this concept, and try to put them down on paper. It could include anything, also including parts from your business model and your user experience, technical feasibility, and so on. The next step would be to formulate hypotheses based on those assumptions, and those should be quite clearly put down. I will tell you more about this and how to formulate them in order to make them relevant and easy to handle. Then you should prioritize those hypotheses in order to make sure that you handle the most critical ones first, because that will make you handle the risks in the project in a better way. You reduce the critical risks as early as possible. Next step would be to find out how to verify that your hypotheses are true or realize that they are false. And then you need a method of doing this. And we believe also that it's important to be clear about a test specification at this stage, because otherwise you will develop a tool or a verification method that is not spot on. You need to be clear what you're going to test and what is a sort of acceptable criteria, acceptance criteria. After that, you create your verification tool and you perform the verification, analyze your result, and perhaps you have to do it all over again and then maybe tweak your hypothesis a little bit. Or if you're happy, you go on to the next assumption or hypothesis on the list in order to verify that one. Of course, you can also work in parallel and handle multiple hypotheses in parallel projects, so to say. So how do you, I briefly talked about this on the previous slide, but how do you identify your assumptions and what is important in this work? Well, I think it's relevant to include all technical competencies that are relevant for this specific project. It could be mechanical engineers, hardware engineers, software engineers, user experience specialists, and so on. And the image there on the right-hand side shows us a little bit of what we call mechatronics, that it's a complicated field with a lot of overlapping areas. So it's important to include all aspects in this in order to make a good product. Also, of course, regulatory when it comes to medtech specifically. Those have very important input. You could also include the people working with the business model, user's perspective, and also product lifecycle management to include all relevant aspects of the product. So having your assumptions in a list or however you handle them, and going to hypothesis. First, I would like to compare requirements, more traditional ones, with the hypothesis and when to use what. Requirements are of course also necessary, and especially when you have all the facts. For example, when you're working with standards and regulations, then you need what you know what you have to fulfill, so to say. So then you don't have a hypothesis. It's a requirement already, and those are also useful when after your assumptions have been tested and verified. So then you handle them as requirements. And in the later stages, as I said, this is the way to handle requirements. But in all other cases, when you have some uncertainties, we believe that hypothesis is the way to handle them. And this will, it could be related to that your product specification and market expectations have not yet been verified thoroughly, or your technical feasibility is not verified. Then it's rather a hypothesis than a requirement. To further explain this, I have well, this is the structure of building up a requirement or a hypothesis. I think an example makes it a bit more obvious. So I will jump directly to an example of this. And if you put it with a requirement approach, you could put it down something like, if you're managing a power plant, you have this power plant system, and we believe that we must have 60 Bluetooth mesh modules, for example, to communicate our sensor information. On the other hand, putting it as an hypothesis could look something like this. We believe that 60 Bluetooth mesh modules can be used in our power plant environment. It will result in improved sensor coverage with easier installation. And we will have confidence to proceed when we have tested 5 of those units working together in our environment. So this is a more open-minded approach. As you can see, we are not rigid, and we have a curious mind, and we want to try and test whether this is the right thing to do. Let me see if we can get the next example here. So another example, let's say you're developing a new barrel or something like that. This barrel is supposed to hold 1 ton of content, but maybe you think that you're supposed to load them in your warehouse, multiple ones on top of each other. So a requirement might be, well, this 1 ton barrel must have a 5 ton load capacity to allow storage 5 barrels high. But with a more hypothesis-driven approach, you could put it this way. We believe this 1 ton barrel need a 5 ton load capacity to allow this stacking of 5 units on top of each other. And we believe this will result in improved logistics by freeing up more space in our warehouse. And we will have confidence to proceed when we have surveyed the logistics operators and simulated the new logistics plan. Just highlighting that this is not only technical things, it could also be just asking people and making sure that we are not doing things that are not relevant in our project. Going further forward here, as I said, it's very important to prioritize your assumptions and hypotheses in order to address the most critical ones first. And there are many ways of handling those. You can have digital tools to follow up on your different hypotheses, or you can just use sticky notes on a whiteboard to follow up on this. Everything, you choose what's best for you. And what's important here is that you should address the one with high impact and the highest degree of uncertainty first. So in this image here, you can see in the upper right-hand side, those are the ones that you want to address as early as possible. So when you have your list of hypotheses and you have prioritized them in the order that you think is the correct one, you need ways to verify those. And I've been touching upon this earlier, but those methods could be physical mockups or MVPs, minimum viable products. Maybe the thing that you come to think of first. But it could also be theoretical studies of research or other sources and interviews and forums with relevant people to get the right input. And it could also be simulations of various types in order to give you the right information that you need. And I think your guiding star in this should be like you should put in as little effort as possible to achieve the relevant input. Trying to make these mockups or MVPs as simple as possible, because you don't need to test it all at once. Just what you believe is the critical things. That's what you should try to verify. So simple, fast, and cheap. That's a good start. Just going back to the cycle here and our iterative approach. When you're choosing the method there, that's number 4 now we're at. And I really want to emphasize that you should create your test specifications already here to make sure that you're working towards the correct target. So coming in on the minimum viable product here, one of the ways of verifying a hypothesis, I would say. This is a picture from the web, and you can see those in different variants, I think. And on the upper row, you can see a more modularized and traditional approach, maybe. And you start off with one module, and you connect modules, and you might develop them separately, and you put them together in the end and make it work. In the middle, you can see also sometimes you consider this a minimum viable product approach, but I'm not sure I agree here, because the different steps here differs very much from the final product. So you didn't really have a clear vision when you started off that project. I would say that the lower one here is the best example of a minimum viable product approach. You try to include a slice of everything, sort of the feasibility, the user experience, and functionality already in the beginning, but you make it in a very simple way, easy and cost effective, and then you add and refine this MVP along the way. And of course you try to get as much feedback as possible for every step you take here. So what's important here is to have a clear vision already at the start, what you want to create or achieve, get feedback, and iterate. And this is a way of visualizing what we want to have in a minimum viable product. We want a slice of everything, not only checking the feasibility of a technology. Then you can use a mock-up or other kind of prototypes. But the MVP should include a little bit of everything. And this is just how it could go if you're not testing modules and testing and getting feedback along the way and trying to build the complete unit before starting your tests. So going back to our development process just briefly, as you can see here, we try to put the identification of critical assumptions already in the pre-study, and the idea generation, of course, you need to do that before you start to identify the assumptions and define your goals and understand the problem. Then when you're entering the iterative definition phase, you start that with a list of assumptions already. So usually the project starts with a quite short pre-study, couple of weeks maybe, and then we go into the next phase with a good list of assumptions to work on. This is a bit more about our pre-studies and what's most important. Define your goals and vision, idea generation, identify assumptions, and prioritize. So what are the main benefits here? We think that you can minimize your risks early, and you reduce them as early as possible. We also think that you work more with an outcome focus, so you're clearer about what your vision and target is. You're not working towards fixed and unnecessary requirements. This is a way of making requirements more relevant and realistic. And we believe this will hopefully take you faster to the market to a lower cost, and that you, along the way, you get a better understanding of your customers, since you include them in your process, and you get feedbacks along the way. So in the end, you get a better product and a better business model. Critical factors from our experience is communication and testing. We believe it's very, very important to communicate within the projects and with different stakeholders. So that is something I really want to highlight. And also that you start testing as early as possible, and you should test frequently because you learn a lot from testing. So, and remember to have an open, dare to have an open mind and curious mind. Question your requirements. Just a quick look at one case that we did here in Uppsala a couple of years ago. It was a product that was supposed to measure your acetone levels in your breath in order to see whether if you're in ketosis or not. In this case, I will just describe what you see on the picture on the right-hand side here. It's we tried to, with the box to the left, we tried to simulate a human being. So we heated some air to 37 degrees. We bought this box from Clas Ohlson or somewhere here, just ordinary shop. And we tried to put humidity into the air and add a certain amount of acetone in it. And then so that simulated our human being in a controlled way. And looking closer to the setup in the middle there, what we wanted to try was to see whether the sensor that we hoped worked for this application was really good enough. So the orange part in the upper part of this image is the sensor. So we could use some standard electronics just to connect it, and the air from that box came through the tubing there, and we could connect this to a PC and make a very simple software to see that we could get the right results. And by this test, we could verify that this sensor really did the job. So it was a very simple sort of test of securing that this sensor was really good enough. And then we could start off the project and develop the product with this sensor as the main component, so to say. And then securing this, which was probably the most critical assumption we had, we could go on with the next assumption, and that was to verify that the users would accept this. And then we put almost the same kind of setup into a simple box, and we let people use it at home and see whether it gave them the result that they wanted. So this was a way of addressing the users and see that they got the right feedback from the product. The next step and the next hypothesis that we wanted to verify was to see whether the market was ready and if the design was right. So we did some design models and showed to different stakeholders and users. And in the end, well, obviously the first design was not the best, but in the end we ended up with a successful product. So, and yeah, this shows that it's possible to success with this kind of approach. Yeah, you've probably seen those kind of images before, but this is something we try to avoid. So it's important to communicate in your projects. So thanks for listening. I guess we might have some questions. I will let Morten read them here.
Yes, thanks, Peter. We got a question regarding if we will distribute this presentation. Yes, and the answer is yes, we will distribute the presentation afterwards. And I will also like to mention that this webinar is recorded and will be available in YouTube in the near future as well. Yes. That's for right now the only question that we have gotten into the questions field. Perhaps there will be some more questions or thoughts afterwards when you see or think a little bit more about it. So feel free to contact us, or otherwise we will of course like to help in every way. We are there for you. So if there aren't any more questions right now, I would like to thank everyone for listening, and thanks for today, and wish you a nice weekend as well.